Hi, everyone. My name is Oded. I'm the CEO and the co-founder of Akeyless, the Workload identity orchestration platform. I would explain exactly what are we talking about, but today I'm going to speak about the key to strong cloud security, about my background 20 years ago as a captain in the Israeli Defense Forces with the cybersecurity. Lots to do with security infrastructure back in the on-prem, as well as the new cloud operation with all the processes from development to product to operations. So I kind of saw a few, and also I had some with the B2C world and not just the B2B. Anyway, let's start from now. So first of all, just a few sentences about Akeyless, no more than this, and then we'll go straight ahead to what we wanted to discuss today. But just for you to know, as I presented myself, the CEO and the co-founder of Akeyless, we're a unified SaaS identity and access management platform that provides several use cases on top of one platform. One is the classic secrets management. The other one is secure remote access in the realm of zero trust privileged access. And number three, data protection with key management all across KMSs and data protection over KMIP, multi-cloud KMS, tokenization, encryption as a service, and so on. We're providing service basically for a number of market leaders in several sectors such as pharma, software, ad tech, online e-commerce, and gaming, as you can see in front of you. We're holding a patented technology to manage encryption keys on a non-trusted distributed environment such as the cloud. It's called Akeyless DFC, virtual HSM. Very unique, and we can later on talk about that. We are providing a global available SaaS all around the world that provides a unique, as I've mentioned, secrets management as a service, secure remote access as a service, and data protection as a service. We're SOC 2 Type 2, FIPS validated, and ISO 27001. That's it for about Akeyless. And let's go straight ahead to speak about I see that, yeah, okay, of course. Let me just close this. Okay, so let's for today, when we speak about the key for managing cloud security, the key component for cloud security, I would like to focus my sayings today specifically around the challenges of DevOps and cloud era. And let's just, in general, let's first see where is it that we're here, right? What are the characteristics? What are the challenges that we're now facing? So first of all, with the cloud DevOps environment and the new Kubernetes and containers, we're talking about having ephemeral resources, right? There's automation, there's infrastructure as code, obviously, but basically resources go up, go down, and that's the difference between what we used to have in the fixed environment, and we have lots of more of those resources, right? We have multiple environments. We have sometimes multi-region. We have the hybrid environment. We have the on-prem, and then we're opening another environment. This complicates things even better because even more because we need to suddenly authenticate cross hybrid environment, and we don't have exactly the same IAM, right? We have the AWS IAM, and internally, actually for workloads, we don't really have an IAM internally in the on-prem. There is no identity and access management for the on-prem machines, and there are all kinds of other challenges around, there is no perimeter around the on-prem, all of those cliches that we all know about, that basically we have more and more environments. There is no one clear segment of the organization, rather than all kinds of islands and you might say small clouds out there that the data of the organization is actually spread between all of those places. Now, one of the another challenges when we speak about the world of where we are not managing our own infrastructure is actually how do you find the root of trust? Okay, the classic HSM, how do a secured module? Basically, how do you keep encryption keys, right? Privileged access, in which how do you provide remote access for those kind of environments? But this is just to start and speak about the challenges that we're having, and I'll go even deeper than that. But in short, as you can see in front of you, we are now in an era and entering an era. Some of you in the stock are already very much aware of this chaos, identity and access management chaos in which we are at, and some of you are about to enter it in the next following months and years. But basically, with all of our environments, we have what is called secrets. Those secrets can be passwords, SSH keys, API keys, certificates, both PKI and SSH certificates, SQL credentials, RSA signing keys to sign certificates and to sign transactions. We have encryption keys. And with all of those, we have multiple of those different tools that are currently managing those kind of credentials and encryption keys and certificates. But for some of us, there are no those tools. And there are all kind of difficulties with those tools, and I'll speak about that later on. But basically, at the last 5, 4, 6 years, in the last years, basically, there were all kind of trends that increased the number of those secrets. Number one trend is about containerization, right? The break of the monolith. Now we have lots of more components. There is actually now more components, machine servers than employees, right? 10 years ago, 20 years ago, you've had more employees than machines, and today we have more machines than employees inside an organization. So suddenly we have lots of those components that need to communicate with each other. There's the DevOps movement, automation. Basically, machines need to create other machines, and zero trust, obviously, where it means that every component in the network needs to be authenticated. All of those trends that I've just named are actually the background of why is it that we're currently seeing more and more of those secrets objects that tend to leak, obviously. So in terms of, facing the challenge of the new realm, of the new era of cloud and hybrid cloud, and what is it that we need to do and start to mitigate the problem, right? So I'll now wish to go more deep into the problems and things that I'm guessing that all of us have began to see, questions like who can access my data, obviously, but more importantly, how can I validate a certain identity? There are all kinds of solutions out there. And I've mentioned, for example, validation of identities like AWS IAM for machines. There's also validation for identities by humans, which is Okta, XAML-based, Azure AD, basically human-based identity providers, and data encryption. Right? How do I protect my data is with the encryption. Where do I put my key? That's a question within the cloud. I'll talk about that later on. But is it how to validate the identity of the one that actually wishes to encrypt or decrypt the data, right? If there's any component inside my network that wishes to decrypt the data, how would I authenticate that particular identity and make sure that no one steals that identity, right? So are all kind of those questions lately that becomes more and more severe again in a distributed environment such as the cloud. Now, the challenge or the step to mitigation number 2 would be around, as I've mentioned, identity validation. And let's go even deeper to that. We're talking about 2 types of identities today with humans and machines, as I've mentioned. Now, they're using, as I mentioned at the beginning, a numerous types of different secrets, right? Credentials and passwords and API keys and certificates and SSH keys to get into, and all of them are just out there. And the problem is that, even if you're using data protection, you're using data encryption, eventually if someone is grabbing your API key and it finds that secret specifically that you were using in order to decrypt the data, then basically that encryption doesn't worth anything, isn't it? So it's all about the ability to validate the identity in a good way, in a good manner, with the good tools. So after validating the identity and after protecting the data with encryption keys, now there's a question of who is allowed to actually go into my database, to my non-structured data, where they are obviously the users of the application. They are the regular users, not necessarily the privileged ones. And then there are all my developers, DevOps engineers, DBAs, IT architects, all of those that actually require what we call a privileged access. Okay, that privileged access is basically the administrator of the Linux server, of the Kubernetes cluster, or the administrator of the database. And well, it is obviously relatively known that with those privileged access, you would need, according to regulation and compliance, depending on the size of the organization, but basically you are obliged to actually audit all of those actions that privileged access are operating within your entire environment, where session recording is needed, and you need to keep on those secrets obviously safe without revealing them to the administrator itself, to keep rotating those passwords. There's all kind of those challenges that you need to make sure. But you know what? the new thing, as I've mentioned earlier, is that the privileged access management is no longer just a question of humans. Now, because of automation that have become more and more widely used in the last few years, machines were actually the ones to create the majority of privileged access, because again, automation, it means that servers need to create other servers. Machine creates machines, and they have all kinds of privileges, obviously, in order to perform those actions. Another challenge in the realm of root of trust, I've just touched it at the beginning, but now let's ask the hard questions. How is it that you can use encryption keys within the cloud? You're not running your own hardware. And that basically means that even if you are saving, you're protecting, you're storing your encryption keys within a cloud HSM, cloud hardware secured model, which is known to be the most secure way, or relatively the most secure way to keep and store encryption keys. How is it that you are not actually the one to run your infrastructure? You're not actually the one to run your own hardware. How can you make sure that you are the exclusive owner of your encryption keys, right? This is a major problem within the cloud environment, as well as all the other ones that I've just named, right? So there are all kinds of places to keep your encryption keys, but today, going towards KMSs, key management systems, and HSM, this is the considered way. But again, there is like a contradiction when you're speaking about the cloud. You're not running your own hardware secured modules. AWS or GCP or Azure are running your hardware secured modules. And how can you make sure that you're protected even from them, from supply chain attack, from insider threats, and so on and so forth? More than this, there's a problem of authenticating, where actually, in order to authenticate to your HSM, let's speak for a minute about the on-prem HSM, you actually need to authenticate to that HSM with an API key, or with such kind of a password or whatever. And this is the whole story of what is called secret zero, right? In order to get to my encryption keys, I need to have a password. And as I've mentioned earlier, if my password is being revealed somehow and compromised, then it doesn't really matter that my encryption key is actually kept within a hardware box, because if someone grabbed that password, then they are being able to decrypt the data that I'm saving in such great efforts. So this is the problem of the chicken and the egg, right? The secret zero. I need a secret in order to get access to my more important secret, and that needs to be solved. So I just named all kinds of, you might say, a large list of different types of new challenges in the cloud. But actually, what we also find, and I think one of the most challenging parts within the new way that we're coding our application, the new way that we're using development, the automation, the DevOps environments, and the new workload platforms, is actually the fact that all of our secrets are currently sprawled away. We see those secrets within the source code. We see them on GitHub, on GitLab. We see them quite often within configuration files and DevOps scripts. We find them within infrastructure as code, tools like Quali, Pulumi, and also obviously Terraform. So you see all of those different secrets and credentials within those scripts actually. And you find them also within the Kubernetes clusters, within the images, within Jenkins CI/CD, within configuration management tools like Chef Puppet and so on. Secrets, basically credentials, certificates, keys, all of them are sprawled away the environment, and they need to have some kind of a home that would keep them, like a store that would keep them in a very secured manner, and would be able to share or to inject and provision those secrets only when they are needed. So to keep it completely clean, to keep your source code completely clean out of those secrets and credentials, so that no one would be able to grab them, no one would be able to have access to those secrets, to keep your DevOps scripts completely clean from those passwords and API keys. And if that's not all, to keep your workload management platforms for CI/CD, configuration management, and provisioning and orchestration, to make all of them very much clean out of those secrets, credentials, as I've mentioned. Just checking up to see if there are any questions before I'll proceed. So I see here questions. Olior, would you better if you'll wait to the end of the session?
Actually, it depends on you. I think it's a general question, so we can answer in the end of the presentation.
Okay. Is it about the KMS shift to KMS to HSMs?
Yes.
Okay,
Yes.
so very quickly, just to provide some context, the shift between key management system to HSM is actually at the level of compliance that you require, the level of security, if you wish, because some cases you can satisfy with key management systems. Take in mind that HSM, hardware secured models, is not necessarily the one to manage the whole key lifecycle management, rather than just being the storage of hardware secure of the key itself. So within, anyway, you need to have them combined, generally speaking. So let's that put aside. If you'd like, I'll be happy to provide more information about those. So a bit information about workload identities. So I've named all kind of challenges in the last few minutes that are actually by Gartner are named in the roof term named workload identities, as you can see here in the title. Now, workload identities include a full set of tools that are in charge to manage certificates, credentials, and keys in obviously an IT environment, engineering environment, DevOps, cloud environment. But as you'll be able to see, and not to speak about secrets management specifically, let's talk about the peripheral solutions right now. So everything starts from the root of trust, from that key management and HSM technologies that basically hold those encryption keys. Those encryption keys are being used then in order to sign certificates, for instance, right? You have your own internal certificates within the environment. There are tools that provide those. Basically, you can find Thales for HSM and key management. You can find Venafi and Key Factor for certificate management. You can find many others that provide also PAM and SSH management. And all of those are providing some kind of a particular subset of capabilities that would provide some kind of solution to the problem of the secrets. How can I protect the secrets? Oh, for so certain use case, I can use the certificate management platform. How do I protect my encryption keys? For some of my use cases, I would be able to use key management and HSM. How would I protect my human credentials? I'll be able to use privileged access management and so on. The problem is, as it goes from that report, and for that, take the analyst's words for that, and you don't need to use mine, but basically this is how it is being explained also in this report. All of those use cases that are still valid in the new world actually do not get new answer with the tools that were created for the past world. So if PAM was created around 20, 15 years ago, and how the secured models kind of the same, you'll find those tools, for instance, not to support the ephemeral nature of the new environments, right? So, for instance, scaling, okay? Hardware secured model is in hardware, right? So if you need to have suddenly auto-scaled software facilities, auto-scaled containers, you are basically limited by the hardware that you're having, okay, in terms of number of transactions. In cases of connectivity and the way to work with tools, there are all kinds of certificate management and PAM tools that we should work with. And well, generally speaking, the API and the SDKs that those kind of services provide are not just easy as we are now used to work with APIs and SDKs, because everything is API driven, right? So it has to do with the philosophy of those products that were designed basically for the fixed environment, for a low number of environments. They are not necessarily thinking about multiple environments and hybrid access, right? For instance, PAM, you need to use a separated solution for secure remote access to get access to your environment, and then to use the privileged access to record your sessions. There are all kinds of those problems within the current tools. And it turns out that the new way to manage secrets, to manage those secrets, certificates, credentials, encryption keys for the DevOps and cloud environment is actually called secrets management, okay? So this is in front of you. This is what Gartner have talked about. By the way, very interesting report. If you'd like, just approach me on offline. I'll be happy to provide you a sneak peek to that report that was published a year ago. So secrets management, generally speaking, is about fetching the credential, with the ability to fetch credentials, to store credentials, to dynamically create credentials, certificates, also to sign certificates on the fly, SSH, TLS certificates, basically to manage all of those types of secrets, all of those types of objects that I've explained about in this lecture, and to do so to any type of identity, basically, both for machines as well as for humans, right? Some secrets some secrets or some use cases would be provided according to secrets management tools, and some would be provided with some extension and enhancement of the secrets management platform. But basically, think of the fact that when you have here human or application, they would require the ability to fetch those secrets on runtime because they would not have it locally. That's the whole point, right? To protect those secrets, to protect those credentials. And then those secrets will be decrypted on runtime or signed on runtime and then provided to the resources themselves. So this is how this works in terms of secrets management. It's about obviously the plugins and authentication. I'll talk about that in a minute. Let's check a little bit about the questions. I'm eager to answer your question as we go. Regarding the Gartner report. So again, talk to us, talk to me on offline. I'll have my email presented for you, but also you'll be able to, let's be in touch. So I'll provide it to you. What would be, Nikita asked, what would be the differences between secrets management and KMS? So KMS is specifically for keys, specifically for encryption keys. With KMS, you would not find the ability to actually protect or to create, for instance, dynamic secrets, just-in-time secrets. You would not be able to create SQL credentials by using KMS. That's the whole thing. With secrets management, you're enjoying a Swiss Army knife of all of those capabilities. With KMS, you're basically having the ability to keep your encryption keys and to rotate them. But what about certificates? So again, secrets management would have all of those use cases all together and wrapped and ready to be used by the DevOps engineer or the DevSecOps architects. Next question by Amit. How does an application authenticate to the secrets management system to fetch a secret? Does it need a secret for that? That's the problem of secret zero. And I'll answer that right immediately, although I've mentioned that. But I'll repeat on that because this is exactly what I'm about to say. Thank you, Amit, for that question. Stay tuned within a minute. And
there is a question. There is a question here. There is a question in the QA by Nikita. So can encryption keys can be stored in an open source tool such as KeePass with a database stored and on OneDrive?
Can encryption key be stored on? So with can be stored on those kind of places. So it can. Is it considered to be secured? Definitely not. Encryption keys need to be managed within KMSs as a start or an equivalent solution for secrets management that would be able to store those keys in a FIPS level integration. FIPS is the highest certification for cryptographic keys management and cryptography by the US NIST. So you'll need to keep encryption keys either within secrets management or key management systems, either the cloud ones, either the self-deployed ones. Obviously, with Akeyless, if you would like, you can go to our website and look at it. But basically, we are not recommending on keeping encryption keys on anything besides those solutions. Okay. Okay, so let's go further and speak about the authentication, right? So with secrets management system, that would be basically providing you the ability to keep encryption keys, keep credentials, sign certificates, and so on. You would have to have within the new cloud environment the ability to integrate with many of those platforms, right? So secrets management basically means that you would need obviously SDKs, so you would be able to add it to your application. So your application would be able to fetch secrets directly within the code or within your scripts. CLI, obviously, to again integrate the secrets management to be able to fetch those secrets within those different scripts. And plugins, let's say plugin for Jenkins, for instance, right? You need within your Jenkins jobs, you need to have all kind of credentials, right? So instead of having it statically mentioned within those jobs, you would be able to just automatically fetch them, and the plugin of Jenkins would be able to fetch those kind of credentials directly from your secrets management system. And the same go with Kubernetes. You would be able to declare those kind of credentials that you wish to fetch, to declare them on the YAML file, and automatically the sidecar, the plugin of that secrets management solution would be able to inject and provision those secrets directly to your containers. The whole thing, by the way, the whole idea behind it is not to have images include credentials, certificates within them, right? The whole point that if someone finds your image, they would not see any secret within it. It's a very important thing. It's very bad practice to have credentials, certificates within it. Okay, I'm seeing another thing around the Gartner report. So we would, again, we would not share it publicly, but we would be happy to have, I'll be happy to have a conversation and a meeting and to be able to share with you some of it. So again, if you're interested, please point us out and just connect with us, connect with me in offline, and I would be able to find the way to provide you the information that you need within that report. So this is just the way to communicate with the secrets management system. Now, the way to authenticate to the secrets management system is exactly either using human authentication or machine authentication. So let's go first for the human authentication. It's far more easy to explain. You have XAML and OpenID and LDAP standards, and they are wrapped by an identity provider such as Okta, Azure AD, and so on. So for humans, they would be able to basically automatically and seamlessly use their existing tokens. Okay, no need for further passwords and so on and so forth. In terms of machine authentication, how would machines authenticate to the secrets management system? This is where there are two types of authentication here. There's cloud-based identity for workloads that are running on top of AWS, GCP, and Azure. And there's the on-prem or legacy-based identity or authentication. So let's first speak about the cloud identities. Within the cloud, we are all enjoying the identity and access management systems of the cloud providers. CIAM of GCP, IAM of AWS, Azure identities within Azure, obviously. This basically means that with secrets management system, you would be able to interconnect an existing workload. For instance, Lambda function that runs on top of AWS would be able to authenticate to the secrets management system seamlessly without providing it any API key whatsoever. You're able to do that, to interconnect with that. With the on-prem legacy world, where you do not have any cloud IAM, right? Within our on-prem, you don't have that cloud IAM, obviously. So allegedly, you would need to use a secret, exactly as I believe that it was, yeah, Amit that was asking it. So Amit said, in order to interact with my secrets management system, I would need to have an initial secret. That's right. So you would need to have an API key, assuming that you're not using cloud identity, which is solved in the cloud, right? So within the on-prem, you would need to have some kind of an API key. Some of the secrets management solutions out there today, some of them provide a very good solution for that, which is the Secret Zero solution. It's like a bootstrapping solution that allows you to completely eliminate that initial API key, and those solutions provide you a solution for that. Again, in that particular case, if you would like, I will be able to take that offline with you, Amit, and to provide you what is a Akeyless solution for that. It is called Akeyless Universal Identity. You're mostly welcome to read about that in our documentation. But basically, you will be able, in having some mechanisms, to avoid the problem of Secret Zero. In some cases, it's a little bit more hard. In some cases, it's much more out of the box, so it will be very easy for you to do so. Now, with secrets management systems, as I've mentioned, the one basically, again, secrets management is the one in charge to make an order in that great chaos of different types of secrets, certificates, credentials, and on that suddenly have become increased in the last few years because of the cloud movement. So with secrets management also comes a new challenge, which is to make sure that that secret management system is highly available and scalable. Now, why am I emphasizing that? The minute that we're saying that your workloads would have to use some kind of a system to fetch secrets on runtime, to fetch credentials, to fetch certificates, encryption keys on runtime, it means that your workloads are actually dependent on that secrets management system. It means that whatever solution that you would choose to act as your secret management system, you would find it highly dependent in terms of availability within your infrastructure. and you would need to make sure that it has all the mechanisms to provide high availability, disaster recovery, and it means that you would need to take care of replication, backup, and monitoring. And this is the new thing around it, right? With the old privileged access management systems, it was a bit okay to keep it, so it's 95% available. You can live with it. If you have 1 hour of downtime, sometimes you can live with it. That was the old PAM legacy things. With the secrets management systems, it's not just about humans, it's now about workloads, and you'll need to take care of the fact that it must be highly available again. And you would need, with multi-region and multi-environments, you would need to replicate those. Sometimes it turns to be a complex IT project. So obviously my suggestion for you is to consider SaaS versus self-deployed solution. And again, would be able obviously to provide you a lot more information about that if you'd like on offline. So to keep some time for more questions, I'd like to just end up with just saying that I just touched the beginning of the solution for the problem for the sprawl secrets, right? You have secrets that are being used by workloads, humans, the problem of data protection. I've mentioned that data protection needs to be managed, and I've mentioned all kind of those data encryption. There are all kind of mechanisms that allow you to basically streamline the whole encryption and signing capabilities within your organization, and to have some tokenization services. It is part of secrets management, and I'll be happy to elaborate, but not today because our time is short. But take in mind, there is also one more thing that we would need to take care of, which is the remote access, right? Remote access by humans is actually a huge use case that requires credentials and short-lived certificates in order to actually happen, right? And I keep mentioning it, that the secret problem is not just about humans, not just about workloads, it's about both too. And the problem is that both of them are using slightly different use cases. So for the human factor, because of the new environments, because of the new way that cloud is running, the perimeterless world, the zero trust movement, and so on, you need to find a solution that would allow you to basically interconnect your internal environment, and to do so with a just-in-time access, so that you would not need to go, one, to the VPN, which with multiple environments, it's hard to maintain, one, to the VPN, then to go across credentials that would need to be provided for you. So actually you're still saving your own credentials within an Excel sheet, within some password manager, whatever. But again, the employee or the vendor will still need to type those. And then you also need, according to regulation and audit, to record those sessions. And you need to do so for any type of protocols, SSH, RDP, kubectl, SQL, and so on. In order to streamline the process, obviously would recommend you to look for those solutions that would provide you an all-in-one solution to be able to have all of those components work together. The tools that were previously created that basically provide a solution for that particular problem of secure remote access, unfortunately or happily, were actually provided for the old places, for the old types of worlds, in which, again, it was combined out of several different tools that required a lot of time and hassle to maintain. Again, VPN, and then PAM solution, and then maybe some connection to certificate management solution. But eventually, I would encourage you, obviously, to look for those solutions that are doing all at once in order to streamline the whole process. Okay, so lots of more other things. Thank you very much for your time. I would encourage you to ask any questions via the email or now, if you would like. So let's answer. Dior, do I have a minute or two to answer?
Yes, we have 1 minute left. So let's see if there are any things. I think most of the people ask for comparisons, comparison with other Vault solution. I don't think we have time. Maybe in the end of the meetup, we will have more time to speak with the finalists.
Okay, so I'll just answer with one quick question. If you're interested directly about Akeyless in comparison to other Vault solutions, I'll just answer with one sentence, and then obviously we'll be happy to answer further, and you'll see more information about our website. but basically far more functionality, a wider product, easier to use, far easier to maintain, if any, because it's SaaS based. And obviously stronger security model. We are FIPS validated by the US NIST, and you'll find our TCO much more appealing. You can see all about it in the pricing in our website. There's a very good answers and very good tables of comparisons, and we would be very happy to, and I'll personally would be very happy to provide you more information. With that, Lior, I'll bring it back to you.
Okay, thank you very much, Oded.